Morning, everybody. Today we are going to solve examination paper, first internal test. Here are the first question. Write algorithm and flowchart to solve the following pair of equations for x and y. Given values of a, b, c, p, q, r. Here, ax plus by equals to c and px plus qy equals to r. Here are the different cases given and the a, b, c variables. Now, comment on result of case 1 and case 2. When there is a change of 0.0001 in one of the coefficients, how interchange of equation affect solution in case 3 and case 4. Devise the flowchart algorithm for solving with the case when one or more coefficients A, B, C, P, Q, R are zero. We will solve our first question. Here we have to solve the pair of linear equations ax plus by equals to c, px plus qy equals to r uh, given in the question. Now here you can see a calculation table where d equals to 2.5 difference which we calculated 2.500 2 in 0.605 and 5 200.1.251 is this. So here in the question where you see that we are multiplying this case 1 with we are multiplying case 1 with q, a with q and b with p. So here it is said the determinant a into q minus b into p. That is the determinant we are finding, and then it's dividing by b to find the x. And for y, we will do this. So for calculating b, we have multiplied a and q, and then subtract y, b into p. So we got the determinant value. Then to find the x, we'll multiply c and q variable and minus b into r and then divide them by d. We'll put the values in the formula and we will get the value of x. And similarly, by putting values in y, we'll get the value of y. Now, in similarly for case 2, we will also calculate x value, y value. Similarly, in case 3 and case 4, in case 4, and now is 4. Now we have for the A section of the question, there we have to comment on case 1 and case 2. So even though the coefficient Q only changes 5.0001 from 2.605 to 2.606, the answer of X changed drastically, roughly from minus 32 to minus 26. This is called the in condition system. It happens because of the determinant is absolutely close to zero, meaning two lines are almost parallel. And the second part, B, it's asked how interchange of equation affects case 3 and case 4. Case 3 and case 4 have exact same equation, just swapping in computer memory, dividing by a tiny number like a 0.00002 in case 3 can cause a massive rounding errors overflow by swapping the equation in case 4. So the large number 1.000 is evaluated first. We perform partial pivoting, which stabilizes the algorithm, ensures computer accuracy, and at last, there is a revised algorithm for zero coefficient. If a coefficient is exactly zero, we might accidentally divide by zero. And the revised step is that before calculating, check if a equals to zero, if it is swapping the entire first equation with the second, if both a equals to zero and p equals to zero, output will be error. System cannot be solved for x. Here we come for the second question. And the second question says, consider the quadratic equation x squared plus 2x minus 2 equals to 0 to obtain find floating point with four digits in mental. Substitute roots in the equation and comment on satisfiability in both cases of x1 and x2. Here, floating point satisfiability of quadratic equation. Computers store decimal using a limited mental. In this case, four digit. This means the rounding of numbers during average step. Because of this rounding, the order in which we add or subtract matters. Step 1. Find the roots of x squared plus 2x minus 2 using the quadratic formula. The true roots are roughly x1 equals to 0.7320 and x2 equals to minus 2.7. Then we evaluate the computations with four digit rounding. So in case 1, x squared plus 2x using x minus 2 using x1, we got using x1 equals 0.7320. So x squared is equals to 0.5358. We have rounded to four digits, and 2x equals to 1.462. At parentheses first, so 0.5358 plus 1.464 is equals to 1.9998. Rounds to maintain 4. Significantly, digits floating format. Subtract 2.000 minus 2 is equals to 0.000. Satisfied. In case 2, 2x minus 2 plus x squared. Using x1, 0.7320 and 2x equals to 1.6464. Firstly, subtract 1.464 minus 2, which gets which gives minus 0.5360. Now add x squared to it here minus 0.5360 plus 0.5358 is equals to minus 0.0002. Not satisfied because it does not equals to 0. This equation satisfied in case 1 but fails in case 2. This proves that floating point math is not perfectly associated. Adding smaller numbers first, then subtracting the larger number often preserves more accuracy than subtracting first. Now we come to the third question. Third question asks about how are the polynomials represented in computers. Write an algorithm flowchart to evaluate polynomial px is equals to a0 xn plus an minus 1 xn minus 1 up to a1x equals to a. Here, in computer polynomials are represented simply as arrays or list of their coefficients. Equation given is an like an minus 1 to a1 a0. Now, Horner's method to evaluate Px efficiently write it as an minus 1 x plus a0. Now, so set result equals to an, loop from I equals to n minus 1 down to 0. Result equals to result dot x plus ai, and then output the results. Now, we have to compare the efforts of brute force versus the recurrence. So here comparing brute force calculating x and directly takes many multiplications. For a polynomial of degree n, it requires approximately n plus 1 by 2 multiplications on n addition. This is slow order of n square complexity. Now recurrence or honors method. This method only requires exactly n number multiplications and n additions. It is drastically faster and much more efficient for computers in order of n complexity. Recurrence relation for dividing by x minus r. This is also known as synthetic division. The remainder and new coefficient b are found via bn equals to a, vk equals to ak plus r into bk plus 1 for k equals to n minus 1 down to 1. I will take it next. The question 4 asks, compare the iterative method of root finding with comments on reliability of conversion. So here we are comparing the iterative methods of root finding. So first, bisection method. How it works? It cuts bracket interval in half repeatedly. 100% reliable. It is guaranteed to converge if you start with a positive and negative point. However, it is slowest method, linear convergence. And then Newton-Raphson method, how it works. Uses slope derivative of the curve to shoot it toward the reef. It's unreliable but fast and converges extremely quickly, quadratic convergence. But it will completely fall or divert if the initial guess is bad or if the slope hits zero. Now, it's thirdly, secant method. It draws a line between two guesses to find the next point. No derivative needed. Reliability moderate, faster than bisection, but like Newton's, it can diverge if the curve has flat spots. And then it comes regular false solution. It is highly reliable. It combines the safety of bisection and always the profit of speed. With the speed of the secant method guaranteeing convergence, so it can slow down on curve functions. Now, we move toward our fifth question. So, what was the fifth question says? It says verify associative and distributive law of arithmetic with fittings 4 digits and provide correct answer. If no number is truncated, and we have given here first and second with their values. Now, to verify associative and distributive law with 4 digits, we are going to prove mathematically why standard algebra rules sometimes break when programming due to floating point truncation. First, associative law a plus b minus c is not equals to a minus c plus b. So here given the a value by which is 5.665 and b value 0.05556 and c equals to 5.644. Converting a notation to decimals, a plus b, we are first solving the left hand side of associative law. So left hand side a plus b, so we calculate a plus b and round it up to the fourth digit. Now we will subtract a plus b, now we will subtract c from a plus b and it gives us 0.0770. Now we will do the same for the right hand side a minus c plus b, where a minus c is equals to 0.0210 and then a minus uh, then add b into that. So 0.201 plus add b, which is 0.05556, which gives us 0.7656. And then we round it up to 4 digits, which will give the final answer of right hand side 0.766. So here you can see left hand side answer is not equals to the right hand side, which shows that this law fails. Now, for distributive law, A B minus C is not equals to AB minus AC. Given A and B and C using E minus 1 for both cancellation. On the left hand side, B minus C is equals to 0.4545 minus 0.04535, which gives us 0.0001000. Or we can write in given the notations 0.1000 into 10 to the power minus 50. Now we multiply A into the B minus C, which will give us 0.0005555. Now we will do the right hand side. We will do the right hand side, which says AB minus AC. So we first multiply AB, which gives us 0.25247 and round it up to 4 digits. Now AC, multiply A into C, which gives us 25.191 into 10 to the power minus 2. Then now round it to 4 digits. It gives 0.2519. And if we subtract them, we will get 0.0006000. And if we see left hand side and right hand side, there are two different answers. So it does not equal. So the law fails due to perfect cancellation. Correct answer, no translation, 5.555 into 0.0001, which gives 0.0005555. With this, we have completed our first internal test paper. Now, in our next video, we will be doing the second internal test paper. Thank you.